This is part 3 of the causal design lecture. So in part 2, we talked about a lot of pre-experimental designs. Recall that a pre-experimental design is one where the experimenter does not have control over who gets the treatment. So subjects self-select into the treatment or control group. And the big problem with that is that you're very susceptible to spurious variables. So other factors could be correlated with whether or not a subject chooses to be in the treatment or control group. And so we've talked about smoking studies and so forth. Now we're going to move on to discuss true experimental designs and then some quasi-experimental designs that have more protection against these confounding spurious factors, yet are still not true experimental designs. So there are two true experimental designs that we're going to talk about here. One is called the after only with control. This is where we have two groups. Now, in real life you could have more than two groups, but the point is you've got random assignment between the groups. So for example, if we had 3 positionings plus a control group, if I'm the experimenter, then I'd have control over who gets to see positioning A, positioning B, positioning C, or the existing control positioning. Okay, we do something and then we take a measurement. So we've seen a lot of examples of this design. The Memphis Housewives example was one. Your previous homework assignment with the German book company is another example of this, where the German book company mailed out the personalized versus the one-size-fits-all version. That's the X, and then they measured what happened. All right, so that's this design. The other true experimental design is called the before-after with control true experimental design. Here we take a pre-measure, we do something, and then we take a post-measure. So I gave you an example of this way back in, I guess it was week 1, with my hearing aid study. So in the hearing aid study, we measured people's attitudes towards hearing aids and their purchase intent. We sent them advertisements for hearing aids, then we measured their attitudes and purchase intent for hearing aids after exposure to the ads. And there was a control group that didn't get to see the ads. These are both very good designs, so you want to use them. When do you want to use which one? Well, there's a kind of an important consideration, and that is how much between unit variation there is between sampling units. Okay, so if there's a lot of heterogeneity among your population, you can get by with a much smaller sample size by taking a pre-measure first. All right, so if there's heterogeneity among your sampling units, you can get by with a much smaller sample size by taking a pre-measure first. Let me discuss an example that I think will make this real clear. Let's go back to the after-only design. Now, let's say that I have a new diet. And this diet, I claim is going to help you lose a lot of weight if you go on it. So, what would happen if I took a big group of people, and then I randomly assigned them to treatment and control, and I put the treatment group on my diet, control group I did not put on the diet. Then I weighed them. So I put them on it for 2 weeks. Then I weigh them. Would this work? And students usually say, no, it wouldn't work. You've got to weigh them first. And that's not really correct. So since I have random assignment, I would expect the weights of the treatment and the control group to be the same. So since I randomly assign people to the treatment and control group, the average weight of the treatment group should be the same as the average weight of the control group. However, if there's heterogeneity in the population, so some people are very heavy and some people are not at all heavy, what you would expect is that you'd need fairly large sample sizes, because with a small sample, let's say I only had 10 people in my weight study and I assigned 5 to each, well then we could work out the probabilities if a certain number, if half these people were pretty heavy and the others were pretty light, there's a high chance that we'd get an unlucky sample where we had too many heavy people in the treatment group to start out with, so therefore my diet is biased. It has a bias against it, or we get too many heavy people down here, and then we still have a problem. Now our inference is going to take care of this. That's why we do hypothesis tests. But the point is, the fact that there's so much heterogeneity among people means you're going to need a pretty big sample size to overcome all that variation that you have across units. All right? So what's a much better way of doing this? Well, take a pre-measure. So if you start out at 200 pounds, then I can see what I can get the effect of the treatment just on that specific unit. All right. Better yet, we could do some blocking. Okay, so you take all the heavier people, and you randomly assign certain heavy people to the two groups. Take the lighter people, randomly assign them, so that you can make sure that both groups are represented with all types of people. All right. So the point is exactly what I said. If there's a lot of variation between units, you're going to need much larger sample sizes to overcome that between unit variation, and you're better off taking a pre-measure. When don't you want to take a pre-measure then? Well, if the population is fairly homogeneous, I guess you're just wasting your time taking that pre-measure. So if all the units start out the same, you don't necessarily do it. There are situations where you cannot do this. So, if you think about the Memphis housewives example, so we're introducing this new line of cosmetics, and what I want to do is find out what's the effect of some pre-catalog advertisements that I send out. Well, if I already send a catalog and measure them, that's kind of a different situation than hitting them with some announcements that this new product line is going to come out. All right. There are other reasons why you wouldn't want to take a pre-measure. Sometimes you have, if the cost of taking these measurements is high, so if you're dealing with paying a subject $50 for take your survey, which is not uncommon if you're dealing with executives or you're dealing with doctors, you probably have to compensate them pretty well. So you're going to need to do the math and think very carefully about whether it's more cost effective to skip the pre-measure and maybe have a bit larger sample, or whether you're better off having that larger, taking the pre-measure. Okay, so due to costs and sometimes just not possible, as I said, you also have to think about the interactive testing effect and the pre-measurement effect. So if you're worried about a pre-measurement effect or an interactive testing effect, then you probably want to use the after-only design. So these are two rock-solid designs. We've talked a little bit about blocking. So there's a saying in experimental design, and it's probably worth me writing this. It's a pretty important quote. So in experimental design, people say, block what you can, randomize what you can't. So what this means is, if you know something about your sampling units that will affect the dependent variable, take that into account up front and then randomize after that. I'll give you an example. An IMC student went out to United Airlines for a summer project one year, and she was looking at creating different email messages that could be sent out to the frequent flyer database to drive incremental ticket sales. So let's think about what United Airlines knows about its frequent flyer database. They know a lot, so they know how often they fly per year. So, if in this database you have some people who are flying 50, 60 times a year, and other people who fly on average a half a time a year, you might expect that those people would respond very differently to an email. So if I'm buying a ticket a week and you send me some promotion, I'll probably use it on my next flight. If I fly every other year, so that's a half a time a year, to visit my aunt, and that's the only time I ever fly, you send me a promotion, chances are I'm going to ignore it. So certain people are just going to be much more responsive because they have a high need to fly. Those who don't have a high need to fly, there's just not much use for your promotion. All right, so you've got a lot of heterogeneity among your sampling units. So do what I just said, block what you can, and that's exactly what this student did. She took this, the different tiers of flyers, and used those. Blocks are kind of like segments, and then she randomly assigned those who are flying one time a week or more to her different email creatives to see which one worked best. She took less frequent flyers and randomly assigned them to the groups, and so forth. So you can save money on sample size by taking that variation into account up front through blocking. So blocking is a really important concept in experimental design, and if you take some of my later electives, we'll talk more about it. Here's another true experimental design. So sometimes it's impossible to withhold a treatment from certain units. So it's just impossible to have a control group in the sense that we had back here with the after-only design. So there's no way I can withhold treatment from the control group. I'll give you a very specific example of this. A few years ago, I was involved with measuring the effects of an integrated marketing communications campaign to get people to fill out their census forms. So every 10 years the U.S. tries to do a census, and they send out a mail packet that asks you to, the basic 11 questions or whatever it is, and you have to send that back. Now, most people do send it back, but a very large, well, it's a large percentage of people don't send it back. So the majority send it back, but then a lot don't. And those who don't send it back, you have to send out canvassers, so interviewers, to get the basic information from them. And so it's much less costly to have somebody mail you a form back than it is to send a person around to that person's house, and maybe they have to come back 3 times to find you at home and do an interview to get that information. So it's highly desirable to get people to fill out their form. So the government invests a lot of money each time it does a census in building up awareness and trying to get people to fill out their forms without sending around a canvasser. All right, so then the question is, what is the effect of this? That was the task that I had to evaluate. So it'd be nice if you could have a control group. That's let's have a true experimental design, and so certain regions of the country get the advertising, other regions don't, and maybe I randomly assign those regions. But such a suggestion would be politically infeasible. So, censuses are used to allocate resources, and the politicians in that district will come to the assumption that the advertising works, and so therefore, how dare you think of withholding advertising from my district, because if that's the case, well, then my district will be undercounted and we'll get fewer resources for the next 10 years. All right, so it's politically impossible to withhold advertising. So what do you do instead? Well, what we did was to recruit a large number of people, and we randomly assigned them to treatment and control. Then we measure proxies for behavior. So we measure attitudes and intentions. Then the campaign hit, and everybody saw the advertising campaign to fill out the census form. After that, we measured attitudes and intentions on the treatment group then, and we compared the two. So that would give us a reading of the effectiveness of that campaign. Now, we didn't do it on the same people because we were worried about the pre-measurement effect. I call you up, ask you a bunch of questions about the census. Next week, the advertisements hit. That could definitely affect your post measures, and could also affect we could have the interactive testing effect as well. So that's why we ended up doing this. Here's another example. We had an outdoor advertising firm in Quincy, Illinois, that wanted to promote awareness of the metric system. So the way they did this, they made 10 billboards with the message 1 ounce equals 28.3 grams, and they posted these around the Quincy area. So the question is, were these effective? Again, we'd love to have a control group, a pure control group, where some fraction of people in Quincy are not allowed to see those ads, but that's just not possible. I can't say to certain people, you're not allowed to drive on these roads for the next 3 months so that you don't see the billboards. So what was done was this design. We measured a certain fraction of people, measured their awareness of that conversion. The billboards went up, and then we measured a different group. I'll just note that this is still vulnerable to history. So something else could have happened here, and we wouldn't know about it. So if there was a special on television on the metric system the same week, and that changed people's awareness of that message, we wouldn't know about it because we really don't have a proper control group. But it's the best you can do given those difficult circumstances. Let's talk a little bit about some quasi-experimental designs. So quasi-experimental designs are not as good as true experimental designs because the experimenter doesn't have control over who gets which treatment. But we can achieve better control over confounding factors with these designs. So one of my favorite designs is before-after with control quasi-design. So here we have a treatment and control group, and we have a pre-measure, and this will give us quite a bit of control over confounding factors. So let me draw a couple pictures for you to explain why we have such better control. So we have a treatment group, and we have a control group. We don't have any random assignment. Now, a a couple things that will this is going to help us against. Let's say we've got a pre-measure of 10, but let's say that there's a selection bias. So the treatment group is just systematically better than the control group. So I'm going to say that the pre-measure on the control group is 5. So notice we've got a selection bias. Now let's say the true effect of the treatment is a +3. Notice that this design is robust to that selection bias. So what would we measure here? It's 13. What would we measure here? Well, this is still going to be 5. Now the effect of the treatment is going to be 13 minus 10. So that's the effect of the treatment on the treatment group, minus the control group. So 5 minus 5 is equal to, well, what is that? 3 minus 0, and it's 3. So my point here is if you have a selection bias, this design is okay. It's robust. It doesn't get broken. Now let's make this even messier. So we're going to get rid of the 5. We'll get rid of the 13. Let's say that there's some history as well. So something else happens. And that something else affects both groups. And let's say the effect of history is a +4. So then what happens? Well, if that's the case, we're going to observe a 17 here. So 10 plus 4 plus 3 is 17. We're going to observe a 9 here. So let's go compute the effect of the treatment. So the effect of the treatment is going to be 17 minus 10, which is equal to 7, minus 9 minus 5, which is equal to 4. So this is all equal to 3. So notice that because we have this control group, the control group makes us robust to a lot of spurious factors like history. So anything that's affecting the two groups equally will be robust because you've got the control group. And the fact that you've got the pre-measure means that you don't have to worry about a selection bias. So this design is pretty robust to these threats to internal validity. So again, the pre-measure is controlled for selection. The control group controls for history or other spurious factors that would affect both groups equally. Another quasi-design is a time series. So a time series is where you just take periodical measurements and then maybe at some point you do something and you keep taking your periodical measurements. I'll give you a little example. Let's make it bigger. Let's say that we have a chewing gum. We manufacture a chewing gum and we're considering the launch of a diet gum. So X is going to be the point at which we launch our new diet gum. So it's a brand extension. What we're hoping to do is to tap into a new market. So we don't want to cannibalize our existing main brand, but we'd like to be able to expand our brand with this diet. So if you think about Coke versus Diet Coke, they hopefully complement each other and allow Coke to expand its reach into different market segments. What I'm going to do is plot the market share of our established brand over time. So what you'll see, it's bouncing around, and then all of a sudden we launch our diet brand and our market share goes down. So this is evidence that we've cannibalized our main brand. Now, it's not a sure thing. There could have been some history. Maybe the competitor launched a new advertising campaign in the same month. Maybe there was something else that happened. We don't really know that because we don't have the control group. But the fact that we've got all these observations out here and all these observations out here gives us stronger proof that we've cannibalized our brand than if we'd only had 2 points, which is what you'd have with a before-after design. If our market share is bouncing around up here at 16%, then it drops for a period and then goes back up to 16%. It looks like maybe a lot of our target market tried the diet brand, but then went back. Here's a situation where there's a real clear trend, and we're in trouble. The diet brand had nothing to do with what happened to our main brand. Likewise here, things are just bouncing around, no effect. So there's usually a trade-off in validity. So if we do things in a laboratory setting, so a laboratory in very general sense, so a hotel ballroom for copy testing, I would call a laboratory. You often have better internal validity with lab experiments because you can shut out all the external noise. You don't have to worry about the competitor doing something to you. You don't have to worry about the effects of the economy because it's all in this lab setting, but you have low external validity. So external validity, remember, is do the results of this test apply in other settings? When you do field experiments, you often have high internal validity, but then you're opening yourself up to a lot more of these external threats, spurious factors. Lab experiments are usually cheaper and faster. Field experiments take more time to arrange. Exposure to competition is another big deal. So if you do field experiments, your competitor can often monitor the sales. So if you're launching a new product, say, competitor can read the sales on that through Nielsen data. If they can buy it from a retailer, perhaps, and then they can beat you to a national launch. Okay, so those are just some considerations when you're designing a test. We'll now discuss these short cases either on our discussion board or in the class discussion.